In this chapter, we will be using calculus as a tool in curve sketching. In this video, we'll be sketching the curve of x plus 2 to the 1/5 plus 4.
Okay, let's take a look at another one. F of x is equal to x plus 2 to the 1/5 plus 4. All right, let's dive right in. The domain. The only part of this that looks like there might be an issue here at all is this to the 1/5 here. But remember, taking the fifth root, you can take the fifth root of anything, whether it's positive or negative, 0, regardless. And so it doesn't really look like this is causing me much of a problem. So I'm assuming here that the domain is element of the reals. Okay, intercepts. Let's do the y-intercept first. Again, I like doing this one first because all I got to do is plug in a 0 and evaluate. And so when I do that, I get 0 plus 2 to the 1/5 plus 4. Okay. And so that is going to be the fifth root of 2 plus 4, whatever that turns out to be there. And I do believe this is going to be some number that's a little bit larger. Okay. Slightly larger than, I'm guessing 5. So slightly larger than 5. I can go to my calculator and figure that out if I need to. But anyway, there we go. So we got to get a decimal number in there. Let's look for the x-intercept now. I am going to make the y-coordinate equal to 0. So that's going to be x plus 2 to the 1/5 plus 4. All right. So basically, when you're looking for the x-intercept, you are solving an equation. So we're going to bring the 4 over. Negative 4 is going to equal x plus 2 to the 1/5. Now, to get rid of the 1/5 here, I'm going to take both sides of this, I should say, to the power of 5. So it's going to be negative 4 to the power of 5 is going to equal x plus 2. Well, negative 4 to the 5th, 4 is 2 to the 2, so this is going to be like 2 to the 10. So that's going to be negative 1,024. And then subtract the 2, negative 1,026. Ooh, that happens quite a ways to the left of the origin. Okay, but good to know. So those are my two values there. Let's take a look at what's next. Let's take a look at symmetry. I am going to plug in a negative into that, so I'm going to plug in a negative in for x. Okay, now in order to see what's going on here, I'm going to have to factor the negative out of that negative x plus 2. And that's going to leave me with negative x minus 2 all to the 1/5, because I do this in steps. Okay, I don't try to do this too fast. I do this in steps. First, I'm going to take it out of the binomial. So I'm still focused on what's inside the parentheses there. Now I've got a negative 1 times x minus 2 to the 1/5. I've got two factors there. So the 1/5 will distribute to both. But the fifth root of negative 1 is just going to be negative. So this is negative x minus 2 to the 1/5 plus 4. Now notice that this isn't the negative of the whole function. This is also not a situation where the negative disappears. So this is neither even nor odd. Okay, so there's no nice symmetry the way I would like to see it. So be it. No big deal. Okay, now asymptotes. Asymptotes. This is not irrational. There are no asymptotes. So that was easy. Kind of like it when that happens. Now, before I move on to the next step here, I want to go back here just for a moment and point my finger right here. Notice that the domain is all reals. It's really important that you catch that the domain is all reals, okay? Because now I'm going to look at intervals of increasing and decreasing. So the first thing I'm going to do here is I'm going to take the derivative. And that's going to be 1/5 x plus 2 to the negative 4/5. And then the derivative of the 4 is going to go to 0. So that's not going to be an issue here. Okay, so I'm getting 1/5 x plus 2 to the negative 4/5. I am interested in where, and actually I might write it like this even. Okay, this is going to be the fifth root of x plus 2 to the fourth. Okay? Now, couple of things here. Notice that this is undefined at x equals negative 2. As soon as you let x equal negative 2 here, this is undefined. But no matter what other value you plug into this, no matter what number you plug into this, other than negative 2, you're going to take it to the fourth power, which will make it positive. Fifth root of a positive is positive times 5 is a positive 1 over. So essentially what's going on here is, if I look at my number line here, at negative 2, the derivative is undefined. But to the left, it's positive. To the right, it's positive. Meaning that this graph is increasing. Okay. I tried to make a point a few seconds ago, so I've already started to set this up here. So hold on a second. So the derivative is positive on the interval negative infinity to negative 2, union negative 2 out to infinity. Okay. Now, this means that the function is increasing. Now, we got to be careful here. Bear in mind that although the derivative is undefined there, okay, although the derivative is undefined at negative 2, the original function isn't. The original function was okay with negative 2. If you plug negative 2 into this, you get the fifth root of 0, which is 0, plus 4 is just 4. So our graph has no problems with it. So what that means is this function is actually increasing on the interval from negative infinity up to negative 2 and including and continuing through out to infinity. It's always increasing. Okay? This is in fact, I would argue this is more than just monotonically increasing. This is strictly increasing. Because it never, the derivative actually never has an opportunity to go to 0. Okay, well that's interesting here. What that means is for our step 6, for our max and min, there's no point here where the derivative goes to a maximum or a minimum. There is a spot here, okay, where the derivative is undefined. So we might think about that as being a critical number. Okay, the critical number of the function here, where x is equal to negative 2, but it's increasing and then increasing afterwards, so it can't possibly be a max or a min. So basically our conclusion is there's no maxima or minima. Okay, let's take a look at concavity. So now my second derivative, nice to have the first derivative just sitting right there. If I multiply by negative 4/5, it's going to be negative 4 25ths x plus 2. And if we subtract 1 from that, what are we going to get there? That's going to be negative 9/5. Right. Okay, so that's negative 4 over 25, the fifth root of x plus 2 to the 9. Okay, well, let's take a look at our number line here. Once again, this is going to be undefined at negative 2. The original function is defined there, but the second derivative is undefined at negative 2. Now, if you choose a number for x that's less than negative 2, you're going to get a negative value to the 9, which will be negative. The fifth root of a negative will be negative. Multiplied by positive 25 will still get you a negative, but negative 4 divided by that, that's actually going to be positive. So it's going to be positive in this interval to the left of negative 2. To the right of negative 2, this will be positive. To the ninth will create a positive. The fifth root of a positive is positive. Multiplied by positive 25 is positive, but when I take negative 4 and divide it by that, I'm going to get a negative. So my second derivative is positive on the interval negative infinity out to negative 2, which means the graph is going to be concave up on the interval negative infinity up to negative 2 and including. Again, remember it's defined there. The second derivative is going to be less than 0. okay, from negative 2 out to positive infinity, which means it's going to be concave down from, from negative 2 out to infinity, and including negative 2. And this takes us right to number 8 here, the possible points of inflection or cusps. This negative 2 here, in this particular case here, this does count as a critical number of the first derivative, okay, because it's where the second derivative is either undefined or 0, but at the same time, we've got the changing concavity, so we definitely have a point of inflection, okay? We definitely have a point of inflection there at the point negative 2, comma 4. And actually, based on how complicated this graph, I don't have much paper left, but I actually think I can just squish the sketch in here. Okay, and actually maybe what I'll do is I'll zoom in a little bit. I'll put the sketch in here. So I know that I'm going to have that point of inflection, and that's really the point that has jumped out at me a couple of times here, at the point negative 2, 4. I also knew that I had a y-intercept here at a point just slightly above 5. So there's my y-intercept. My x-intercept is way, way over there. No biggie. My first derivative, okay, there was an issue at negative 2, but it was increasing here and increasing here. My second derivative was concave up here, concave down here. Okay, now let's put this together. So in an interval where I'm increasing and concave up, it's swooping up like this. Now my x-intercept is way, way over here. So it's basically coming up like this, and it's curving up. Now here's what's interesting about this point right here. This is a point where the first derivative was undefined. Now think about that. The first derivative is the slope of the tangent, and it's undefined, meaning that this thing goes vertical. And that's what makes this particular question interesting. It's got a vertical tangent line right there. Okay, that's why the first derivative is undefined there. But it's defined at the function, where x is negative 2 is still defined in the function. I still got a point there, negative 2, comma 4. Then I'm still increasing, but concave down. So it's going to go like this through the y-intercept, and then it's going to continue to increase, but it's going to be concave down. So it's this special little graph right here, and that doesn't quite look the way I want it to. That's got a vertical tangent, so the graph goes vertical right at that point right there. Anyway, interesting graph.